It started with a storm. In 1901, sponge divers near the Greek island of Antikythera stumbled upon a shipwreck buried beneath the Aegean Sea. Among the marble statues and amphorae, something unexpected emerged: lumps of corroded bronze, broken gears fused with time. No one could have imagined what they had found, a mechanical artifact that would rewrite our understanding of ancient science. At first glance, it looked like scrap, but inside those fragments was a gear-driven mechanism so complex that nothing else like it would appear for another 1,000 years. This was not decoration, this was computation. Archaeologists were puzzled. How could ancient Greeks, people we associate with togas and temples, build something that resembled a clock, a calendar, even a computer? As researchers painstakingly reconstructed the fragments, they discovered that this device could do something stunning. It could predict eclipses, but how and why? The Antikythera Mechanism, as it came to be called, wasn't just a tool. It was a portal into the scientific soul of an ancient civilization, one that understood the heavens with uncanny precision. Let's step inside the machine. The Antikythera Mechanism is about the size of a shoebox, yet contains over 30 interlocking bronze gears, some with teeth smaller than a grain of rice. When turned by hand, these gears moved dials and pointers that mapped the cycles of the sun, the moon, the planets, and eclipses. On the front, two main dials. One showed the Egyptian calendar, the other tracked the zodiac. On the back, spiral dials traced the 223-month Saros cycle, which predicted solar and lunar eclipses with uncanny accuracy. Think about that. Ancient Greeks, over 2,000 years ago, had built a machine that could tell you when the next eclipse would happen decades in advance. Without telescopes, without satellites, just math, metal, and mastery. One pointer even displayed the moon's phases, factoring in its elliptical orbitan astronomical truth only confirmed by modern science centuries later. It wasn't just mechanical, it was beautiful. The gears turned with purpose, each rotation a cosmic rhythm. A hand-powered calendar of the universe. This wasn't superstition, this was applied astronomy. The big question: who made this? Most historians point to the 2nd century BCE, a time when Greek minds like Archimedes and Hipparchus were exploring math, astronomy, and mechanics. Some even speculate that Archimedes himself may have inspired or contributed to its design. Others suggest it was built in Rhodes, a hub of Hellenistic science and home to skilled instrument makers. But here's the twist: this wasn't a mass-produced device. It was one of a kind, handmade, delicate, possibly commissioned by a wealthy patron or scholar to model the heavens or to impress them. Why build it? Some say it was a teaching tool, others a ceremonial object or a navigator's guide. But perhaps it was all three: a cosmic calendar, a clock of the gods, a window into time itself. It proved that the ancients didn't just observe the sky. They understood it and they wanted to replicate it. They didn't merely tell time. They tried to possess it. Now the tragedy. After the Antikythera Mechanism, we see nothing like it for over a millennium. No other mechanical device of this sophistication appears until the medieval Islamic astrolabes and 14th century European clocks. So, what happened? Wars, fires, empires fell. Libraries burned, especially the Library of Alexandria, a place where such knowledge might have been stored. The craftsmanship and astronomical insight behind the Antikythera were simply too advanced for the times that followed. The world wasn't ready to carry it forward, or maybe it was hidden, forgotten, dismissed as myth until the 20th century forced us to rethink the ancient world. The Antikythera Mechanism is more than just a relic. It's evidence of a lost lineage of knowledge, a reminder that progress isn't always linear. Sometimes it regresses, sometimes it sinks to the bottom of the sea. For decades, the mechanism was shrouded in corrosion and mystery. But 21st century technology changed everything. In the early 2000s, a team of scientists used high-resolution X-rays and 3D scanning to see inside the bronze. What they found was mind-blowing. Inscriptions, diagrams, gear trains so delicate they required modern physics to decode. Mathematical models were developed to simulate its operation. Experts reconstructed working replicas. And as the pieces came together, one thing became clear. This was a machine designed not just to observe the sky, but to predict it. The mechanism's creators had embedded astronomy, engineering, and philosophy into bronze. It was an ancient form of programming code written in gears instead of software. It's now widely accepted as the world's first analog computer. But its biggest legacy, it shattered the myth that ancient people were simple. So, what does it mean that a 2,000-year-old machine could predict eclipses better than most medieval tools? It means that we've underestimated the past. It means human curiosity, intelligence, and innovation are not modern inventions, they're ancient instincts. The Antikythera Mechanism whispers across time that before the internet, there were ideas. Before factories, there were fingers guiding gears. Before the modern world, there were minds daring to model the cosmos. And perhaps there are still other lost machines waiting to be found, still buried in sand, sea, or story. So the next time you look up at the night sky, remember this. You're not the first to wonder when the next eclipse will come, but you might be the first in centuries to know who already knew.